All right, hello everybody. Today we're gonna do a very basic introductory level tutorial here, really discussing some of the fundamentals of just importing models into Houdini, setting up and animating cameras, and then bringing all that into Solaris or the stage context for rendering. So at the end of this, we should be able to render out some sort of imagery like this with a model that you download from Sketchfab or TurboSquid or make yourself. So let's get into it. All right, so here we are in a blank context in Houdini, just starting off with a fresh file. First thing to remind everyone is that organization is key once we start referencing different files that are outside of Houdini. So I have a folder structure for this project that my class at East Stroudsburg University is working on. And right now we are in production, and all of our Houdini files are in this Houdini folder. So when we're saving, we want to make sure that we save our HIP files in the Houdini folder, and everything that you're referencing is housed in this file structure. Otherwise, things will get moved around and go missing and not load anymore, and it'll be a real pain. So I'm gonna just start off the bat by saving my HIP file, which is what we call a Houdini file, is a .hip, and I'll put that in my project folder here, in my Houdini folder, and I'll just name this example file, V001. So remember, it's always good to version your files and save iterations just in case something goes wrong, which likely it will. So first thing I want to do is just import a model. In this case, I'm going to use the statue of the Virgin Mary. And so there's a couple ways of doing that. What I usually do is just lay down a geometry node, and I can name this something like Mary statue, something descriptive. Double click to dive into that. And I will use what's called a file node here. So the file node lets you reference any sort of external geometry you might have saved up from other 3D softwares or downloaded or even had scanned and whatnot. So with the file node, we can simply change the file path by clicking on this little arrow, and you can see right off the bat it is looking at $HIP. So this is a wildcard that is indicating the location of my Houdini file, which in our case is right here. So you can see my file browser is matching the same structure here. So it's just a shortcut to get you to where you saved. And most of the time you'll be putting your geometry in a folder called Geo. So that's what I did. So I'll double click on that. And here's this Virgin Mary statue that I downloaded from TurboSquid. And I'll open up the .obj file. And here's the model. So it popped in here into Houdini, and I've successfully imported it. So that's great. This is one way of importing models with this file node. You can also go up here and go File, Import Geometry, and I could double click on my object file or .obj, and it does the exact same thing. So now I see I have a file node within a geometry node. Exact same idea here. It just automates the process a little bit. There are specific file import options for different file types. So you can see FBXs and Alembics. Those will have a different node structure depending on how they're set up. If I jump back inside my geometry node here, you can see there's specific file nodes for Alembic. There's different import settings for FBX, but really they're all sort of variations on this file node. In general, I would say when dealing with OBJs, just use the file node here. If you have some more complicated FBX with animation or Alembic, I might go ahead and do the file import, Filmbox FBX, or Alembic scene. All right. So at this point, you might be wanting to do some sort of scaling or different color treatments or what have you on your actual geometry. One thing I usually like to do is resize this. A lot of the times the physical size of this model will be either too big or too small. We can do that with a transform node, and I can just scale this down a bit. Houdini is unitless, meaning there's no real scale to the units, but in general the simulations will assume 1 unit equals 1 meter. So I could make this statue a little smaller, and you would see that this now is about a couple meters high, or 2 units. I could middle mouse on this, and I see that my size here is at 1.8 in Y, and I think that should be about right. So this is like a big statue here that we are dealing with. All right, so I scaled it down. There's also a handy match size node that you can use to specify an exact target size. So if I wanted this to be size 2 in Y, I could then set 2 here, click scale to fit, and you can see it's doing its best to scale it down to this bounding box. If I wanted it to be specifically to the Y axis instead of best fit, I could just change this drop down to Y. And now we're at exactly 2 meters in height. You can see by default, it centers the model at 0, 0, 0. If we wanted to align this to the grid, I could just set justify Y to minimum, so the bottom of the model. And so now we have pretty much the same thing that I did with the transform node. Usually I'll use match size because it's a bit easier to specify what size you want. All right, and if we look back to this render, I've given this sort of a treatment where I've really highlighted the curvature of the model. Let's go ahead and just set that up. There's a node in Houdini called measure, which allows you to measure a lot of different aspects of your geometry. In this case, I want to measure the curvature here, and I want to measure it on the points. And if I click on the eye on the node and then show the curvature attribute, you can see with this visualization, it is giving me a color representation of how curved these surfaces are. I might want this to just become a 0 to 1 value so I could use it in texturing. So I'll go ahead and check baked visualize range into output. And this just remaps these values from 0 to 1 or from black to white, so they're a little easier to work with. So we'll play with this in a second when we start rendering. And you can adjust some of these settings to get different sort of looks for your curvature. So let's keep going here. I might want to then resave this object to disk, and this is referred to as caching. So right now what's happening is I'm loading in the file, and then I'm doing some operations to it, and I could do tons of things to it. And the more things I do, the more time Houdini takes to compute all those nodes. To speed up rendering, once we start rendering, I might want to cache this out. So to do this, I can press tab and put down a file cache node and hook this up. This lets me output and re-import models or anything, effects, simulations. You can do it all with this file cache node. It has a lot of options here. Just for simplicity's sake, I'm going to turn it to explicit. And now I can just specify where I want to save this geometry. So in my case, I do want to save it to my geometry folder, and I will name it. What I usually like to do is delete this $hip name variable and just name it after the node. So $OS here is short for a variable for operator string, which is referencing the name of the node. So I could name this Mary Test Statue, for instance, and now when it saves this file, it'll call it Mary Test Statue dot frame number, $F is frame number, .bgo.sc. In our case, this is just a still model. There's no animation to it. So I'm going to uncheck time-dependent cache and just get rid of this $F. Now when I press save to disk, you can see a little hard drive symbol appeared. And if I view this, it is now loading this geometry from disk. Specifically, this file it just created. If I go into my folder, we can see Mary test statue.bgo.sc. So this is the actual geometry file that was created, and now this node both exports it and reloads it. So if I did something, for instance, let me go ahead and put down a color node here, and I'm going to turn off my visualization just by pressing this button. If I made the statue red, for instance, when I view this node, the statue is red, but when I view the cache file, it is not red because it's still just referencing off the Mary that we saved. If I wanted to resave this cache, I could just press save to disk again, and now it saved it and it turned red. In our case, I don't want that, so I'm going to remove this node by selecting and pressing delete. And I'll just press save to disk again, and you can see it goes back to this neutral color. We still have that curve attribute on there. We can view that with the visualizer, but it isn't affecting anything right now. The way this file cache node works, it's not brand new, but relatively new node. What you had to do before is put down a ROP node, which is a rendering node, and we can do ROP geometry export. This node would save out your geometry, so I could call this $hip, and I'll just name it the same thing, and I'll say this is Mary ROP test. So when I press save to disk here, this node saves the geometry to disk, and I can open up the file and I see, yes, indeed, we have Mary ROP test. I'll delete that and just do it again just so we can see save to disk. But it's not actually reading it back in. To read it back in, I would have to put down a file node and then reference that geometry. So I could navigate to that folder and select Mary ROP test, and now I'm actually reading it back in. So this node right here just combines these two nodes together. It's just a little quality of life thing, but either way works. The only hazard of this node is sometimes you might accidentally save to disk or overwrite previous nodes. This sort of structure is a little more easy to tell what's going on. But I like the file cache node just for its simplicity. So let's go ahead and now look at rendering this out. So I'm going to just put a null down. This is good practice at the end of my chain and call this out underscore Mary statue. One thing I forgot to mention here is that this extension .bgo.sc, we can make this anything we want. I could change this to .obj, and you can see it disappeared because this file doesn't exist yet. When I press save to disk, it pops back in because it creates that file, then loads it back in. So you can specify any sort of file type you want in this node. It could be an FBX, OBJ, what have you. BGO is Houdini's native file format. So bgo.sc is just a variation of this. And this loads the fastest in Houdini. So if you're just staying in Houdini, I recommend sticking to .bgo.sc. You can save anything to this file type. So you could save simulations, you could save particles, which is a type of simulation. You could save geometry. This is a very good universal format for within Houdini. It wouldn't work in other 3D software though. So that is sort of the basics of bringing in a file and saving it out. Let's start looking at setting up some camera animation. So I'm going to jump back up to my object context and put down a camera. So I just pressed tab and typed in camera. To jump into this camera's point of view, we can see it creates it at the origin at 0, 0, 0. I can go ahead and just click this drop down and select cam 1. And you can see if I try moving the camera, I just jump out of it. So what I need to do is press this little lock icon, and then it actually allows me to change the position of this camera here. This is really to prevent you from accidentally auto keying your camera. This happens all the time to me in other software where you might just be in the camera and you don't realize it, and then you add a bunch of keyframes and mess up your entire animation. So the lock means you're actually locked in and adjusting the camera. So I'm just going to make a very simple camera animation here where I just do a sort of dolly in, getting closer to the statue's face. So I will go ahead, kind of position the camera where I want it on my first frame, and I'm going to just Alt left click on whatever parameters here I want to keyframe, and you can see those turn green, and we can see we have a green tick mark here in the timeline. I'm going to go to the end of my timeline and just zoom in a bit, or dolly in, and maybe pan the camera just slightly. And I've made a camera animation. You can see right here, auto key is on. So as soon as I moved the camera, it created a keyframe. If you didn't want that to happen, you could click this little drop down and turn auto key off. And then you would have to manually create keyframes, either by alt clicking on the parameters. You could also right click and go keyframes, set keyframe. You could also click on the little key. So always a million ways of doing anything in all these 3D packages. All right, so I have a camera animation here, and you can see it's playing quite quickly. That is because I don't have the real-time toggle on, which is this little stopwatch. So I'll go ahead and click that. And we have this kind of subtle camera movement now. And that's all good. One thing I might want to start looking at is I'm going to click on this little menu, and really we should do this before we animate, and just double check your frame rate is correct. So this project is at 24 frames per second, and it's set at 24. You want to make sure you're animating at the right frame rate before you're starting animation, otherwise it'll end up shifting all your keyframes around. Now I also might want to look at my graph editor here and adjust some of the easing of this camera. So I can go to Windows, Animation Editor, and this is much like the graph editor in Maya or in any animation software really. So we have all the graphs here of all my different parameters. The general rule here, I'm going to just take a look at translate.x. I can press F to frame this sort of spline, and you can see by default Houdini has these Bezier tangents. So the rule of thumb here, this won't be diving into animation in this sort of walkthrough, but the more horizontal these lines are, that means the slower the animation is going, or it's actually slowing down. So this graph tells me that the animation is at a standstill at the beginning, and then the camera starts moving slowly. It speeds up and then continues at a linear constant velocity, and then it slows down. If I want to adjust this and just make my curves linear for everything, I could select my my keys and just press this linear or straight tangents, and that will make that curve straight. I could also, I'll go to translate.y. I could also manually adjust these tangents just by moving them to get more of a linear pathway here. But I'm going to just make my tangents linear for everything. So I'll select all my curves, press linear, and now we just have a constant camera move during this 240 frames. All right, nice. So now I might want to start rendering this. This is relatively new workflow in Houdini. Usually you would set up your rendering operators here in the out context and just render out what you have here. Now what we do is use this stage context. This is also called Solaris or LOPS, lighting operators. The stage is where you create your materials, create your lighting. You can also create your cameras here. And it's all USD based, which means Universal Scene Description. I won't be getting into the nitty-gritty of what that means, but we'll just look at the basics of how we can start bringing in objects and cameras and rendering them in Solaris. So there's a couple ways of bringing in geometry here. The one I use mostly is this SOP import node. So I'll go ahead and I'm in my stage network and I press tab and I put a SOP import. This lets me use this SOP path and bring in any sort of models or objects that I made in the OBJ context into the stage context. So we previously were in OBJ, now we are in the stage context. So I can navigate to my null that we created, the out Mary statue null, and press accept, and we can see the statue pops into there. One thing I like to do in working here in the stage is switch my interface to the Solaris interface. So I can click on this little drop down menu and click on Solaris here. And this just changes my UI a little bit. I can see the hierarchy here, and really what the stage context is doing is creating this hierarchy. You can see by default it has named the Mary statue SOP import. So that is happening here. It's using the $OS variable, which is once again operator string, the name of your node, to create a name in this, almost like the outliner if you're familiar with Maya. So I'm going to just name this Mary statue, and you can see in my scene graph hierarchy it is now called Mary statue. What I like to usually do to stay organized is just make a folder by doing /geo and put all my geometry in a geo folder. This is just organizational best practice here. So I got geometry imported. Nice. Now I might want to import my camera. So I can't use a SOP import to do this because the camera really isn't a surface operator. It's just an object. So it's one level above SOPs. So there's a special way of doing this, which is called scene import. And you can really import anything with the scene import. So you can make lights in the object context and import them. You could make cameras. You could even make materials. So in this case, I really just want my camera. So I'm just going to select the scene import cameras option here. And the way Solaris works is we just wire these nodes one after the other to create this hierarchy here. So I'll just wire this in and then put my display flag on scene import cameras. And you can see by default, it just brought in my cam 1. The reason this is happening is because we have this filter set to cameras and we have the star next to objects, meaning essentially bring in just every camera in your object level. If I went back to object level and created another camera and then switched back to the stage, you can see that camera is also being brought in automatically. If I only wanted to specify specific cameras, I could delete this asterisk here and just go to force objects and select my camera that I wanted to bring in. Just as an example, I'm going to disconnect this. I can also use the scene import to import geometry. So I could do scene import, put my view flag on here, and specify the Mary statue specifically and bring it in that way as well. You'll notice that when I do it that way, you'll have to be careful because it's going to bring in whatever is just currently visible. Whoops, actually, let me put a number there. So if I went back into my object level and then put down another node in here, so I'll just put down the pig head and switch the visibility to that, you can see it's now importing the pig head. So that's a reason, another reason why you have this end node to specify what exactly we want to export out of this context. All right, so jumping back to the stage level here. Whoops. I'm going to go ahead and delete the scene import. So largely the same, right? SOP import, scene import. They're doing similar things here. Scene import, you can really import anything you want with. SOP import is a little more specific. Can only do SOP level things, not cameras or lights. So I can go ahead and switch my view to cam 1 here, and I have the exact same setup we were dealing with before. Cool. Now we need to start thinking about adding materials and lights to actually render this out. So to do that, we can use something called a material library. So I'll go ahead and press tab and type in material library. And within this node, we can make all the materials for our scene. So I'll go ahead and put my view flag here and then double click on the node to dive in. And what we'll be using almost all of the time, for this project at least, is called a Karma Material Builder. So I just press tab and I press Karma Material Builder. Karma is Houdini's render engine, newer render engine. It used to be called Mantra. And I can now rename this material, and I'll call it Mary Statue Matte. I'll double click on this material to dive into it. And this is very much similar to any sort of material graph you'll find across Maya, Blender, Unreal. Any 3D package is going to have this fairly standard, physically based metallic roughness or specular glossiness material. You may not know what that means quite yet, but that's okay. Just know this node right here has almost all the parameters we would want to adjust for creating a certain look for this statue. So let's say we wanted this Mary statue to be red. I could select red here for my base color. We can notice nothing happens yet. That is because we made the material, but we still need to assign it. So there's another node that can do that. I can also do it in the material library, but just to stay organized, I usually put down an assign material node and connect that up. And on this node, I can specify the object or the primitive. This is kind of Solaris USD talk primitives that I want my material to be assigned to. So there's different ways of doing this. What I usually do is just drag my object right there and drop it to the primitive slot from the scene graph, and then I just drag and drop my material. And you can see as soon as I drop the material here, the Mary statue turns red. So I've created a material with the material library, and I assigned it with the assign material node. So now I need to add lights. If I press tab, I can type in light, and there's different light types here, but I'm gonna just, for now, put down the light and put my display flag on it. And I'm gonna move my camera out a little bit, and you can see we put down this point light by default. I'm not going to go into all the specific settings on lights in this tutorial, but just know you have all these attributes you can adjust. I would focus on intensity, exposure, which is just the brightness of the light, and color for the most part. We can also change our light type. I might click sphere so we have a little bit softer shadows. Much of the time we'll be using rectangle lights, which are the same as area lights. You could also use disk, which is a different shape. And I can move this around, position it, scale it, kind of position this wherever I want to. I might up the exposure a bit, and we get an idea of how it looks in the viewport here. But we won't really know exactly how the lighting and materials interact until we launch a render. So let's go ahead and try that. To do a render preview, we can just switch our viewport here from the perspective button from Houdini VK, which is Vulkan. That's just the default viewport visualization here, to Karma XPU. So XPU uses your GPU. Likely it's going to be faster than CPU. So I'm going to go ahead and click Karma XPU. It'll take a minute to start, and then you can see your render starts developing. Cool. And I can move the camera around, and I'll see this update here. I could go ahead and jump back into the camera I imported just to see how the lighting looks from that angle, and get a sense of that. Maybe I want to change my materials now. So I could jump back into my material library, back into the Mary statue. I could do things like adjust my metalness if I wanted this to be like a metallic sort of chrome look. I could change this to a bright color and metal, set to 1, jump back to my lighting, adjust some of my exposures. I can click enter on any node to get all of this interactive viewport functionality, and you can see there's all these little tool tips. So if I wanted to place the light, I could try out some of this functionality where I hit specular, for instance, and then I can just click to control where a specular highlight will be placed, and this will automatically move my light around. So this can be sort of a nice way of working in conjunction with just jumping out of this view and moving your light around manually. Okay, so now I have this metal sort of Mary statue. Maybe I want to use that curvature attribute we created before. So I'm going to jump back into my material library and bring in that attribute to adjust some of the settings on my material. So to bring in any attribute you create on your geometry, you can do it 2 ways. I could do it with a USD primvar reader or a material X geometry property value here. These are essentially the same exact thing. One is specifically for material X, which is the materials we are using by default in Karma. One is based upon USD. But let's just try it out and see how they work. These are very much the exact same thing in VOPs as using binds, if you're familiar with that. Binds and bind exports. So I'll go ahead and just type in whatever attribute I want to bring in. So in this case, it is curvature. And you'll just want to double check that you're using the right signature here. So curvature is a float. If you were bringing in a color, for instance, that would be a vector or a float 3. Those are the same thing. You just want to make sure the type is correct here. And I'm going to just plug that into base color. And I'll go ahead and turn off metalness just so I can see this. And you can see it's pretty bright here, but we are indeed bringing in that curvature value. I could remap this, and just for the sake of illustration, I'll go ahead and use this other node to do it as well. So I'll type in curvature and connect it, and you can see we get the exact same thing. I usually use this USD primvar reader, but for our purposes, it's interchangeable. I might want to remap this just to get a little more contrast here. So I'm going to put down a ramp parameter and plug it in. And this node just lets us remap any sort of values that are coming into our material network. So maybe I'll just want to sort of clamp the blacks a little bit, bring down the whites just to get a little bit more of a contrasty look here. I could put a gray and sort of adjust the gamma on this a little bit. And now we have something like this. I'll jump back up to the stage network here, and I'm going to now adjust my lighting since I changed my material. And we have something like this. This is fine. Let's say I wanted to make a change to this. Like maybe I want to add a little more resolution to my geometry to get a little more detail in my curvature. I could always hop back to the object context, go in here, and before my cache, I'll go ahead and add a subdivide node. So I'll stick this into my chain, and I'll go ahead and switch my subdivide type to open subdiv loop. That is good for a triangulated mesh. So that just gave us a little more resolution here on our geometry. So when we do the curvature computation, we'll get a little more detail here. And since I made a change here, I'm going to need to press save to disk so that geometry updates. And now I will hop back to the stage context. And we have a little more sort of detail in that curvature. All right, so at this point I would just continue tweaking things, right? I might add more lights. There's a physical sky light you could also play around with if you wanted more of a outdoor sort of sun lit environment. This can be pretty useful for previewing materials. You could set up sort of a 3-point lighting setup, and you would just keep on stringing these lights one after the other. So you could add as many lights as you want here, adjust the positions of them. Maybe this would be a red accent light. So now we have sort of a daytime setting, and there's some sort of red light coming from behind the statue. One thing I noticed here is that our scene is sort of out of focus here. That is because by default, we are bringing in the focus distance and everything from our camera. So if I wanted to adjust that, I would need to jump back over to my object context and make an adjustment to this camera's focus distance. So right here we have our focus distance under sampling. We would want to dial that into the distance that Mary is away from the camera. To do this, I could press enter and just manually adjust this focus handle here and place it more in line with the statue's face. And I could keyframe that at frame 1. So I'm going to go ahead and go to frame 1, adjust the focus distance so we're right there on the head of the statue. I'm going to go to frame 240 and adjust it there again. Alt-click to keyframe. And I'll change my animation handles to linear for that to match the rest of my animation. There's automated ways of doing that as well, but we can explore those later on. So now I'm going to jump back to my stage, and when I'm in this camera, you can see this is much more in focus. If I wanted to sort of adjust that while previewing my render, I can press this thumbtack and then jump back to the object context and adjust the f-stop. So that's the same as adjusting your aperture. The lower this number, the more out of focus the out of focus areas of your image will be. So you can see if I put a tiny value, we have super out of focus areas and just slightly a slight slice of in focus areas. So I could dial that in, but I'll keep this at a relatively larger value. This is really based on how a real camera works. So we have a relatively just in focus shot here. Okay, at this point, we may want to render out our animation. I'm going to go ahead and press the bypass button to disable that sky, and I'm going to just fiddle with this point light a bit and move it sort of in front of the Mary statue. And I'm going to make it a sphere light because I want a little bit softer shadow, so I'm going to make my light a little bigger. I'm going to move it away a little bit more. And I'm just jumping back and forth between my camera here. Let's say we want something like this. It's almost like a stylized sort of comic booky look to this. I'm going to go ahead, and I don't like seeing all these little UIs. I can toggle those off with these display geometry and light guides here. And then I'm going to think about rendering out this as a sequence. So to do this, I need to put down a Karma render node. So I can press tab and just start typing karma, and it's this first node here, just this karma node at the top. If I click that and put it down, it automatically makes 2 nodes. This first node is in charge of setting all your render settings. So your resolution, the amount of samples, this controls the quality, all of that is on your karma render settings. The USD render ROP simply is there. Really the main thing you'll adjust is just the frame range. So I'm going to go ahead and plug in the light and then jump to the karma render settings ROP. And you can see right now it gives me a little exclamation point warning. I can click on that and see what it says. It says cameras, camera 1 missing from input, unable to compute resolution. So it's just yelling at me because I don't actually have a camera called camera 1. We'll want to just click the drop down and set it to cam 1, which is the camera we imported from our object level. Now I might set the resolution to something like 1920 by 1080. I want to render using the Karma XPU engine to increase my render time. And I want to also set my export path here. What I usually like to do is set this to hip/render/os/os.f4.exr. So what this means is it's going to create a folder in my render folder named after the node, and then each image will also be named after the node. So I could call this something like Mary Test Example. And now this will create a folder called Mary Test Example, and the files will also be called Mary Test Example. We would want to adjust our amount of samples until we have the right sort of image fidelity. So if this was super low, you might see that my image starts to become very noisy or pixely. We can usually, this will really depend on your shots, but you want to have this as low as possible while keeping a clean render. The other thing we could play around with is using some denoising. So you could use this drop down menu under filters and change it to something like NVIDIA Optics Denoiser. And this will let you have lower samples and then just denoise your image. You don't want to rely too heavily on that, or it'll start creating sort of artifacts. So if I put my samples really low, in our case, it doesn't really change things because we don't have that complex as of a scene, but you'll start to notice you'll get a lot of weird sort of smudging and smearing if your samples are too low and you're using denoising. I'm going to just stick to a lower setting here. So I like to do it in powers of 2. So I'm going to decrease it to 64 samples. And I'm going to use this like a test render. Actually, I'm going to go all the way down to 32. And we can see this image took 2 seconds to render. So that's good. That would be nice just to do a quick preview, make sure everything's working, and then I might re-render it at a higher sample rate. All right, so there's obviously more intricacy. There's a lot of stuff on this node, but those are the main parameters we'll want to play around with. When you're ready to render, I can just go down to this USD render ROP. I can change this to render specific frame range. By default, it's going to take the values of the start and end of your timeline down here. If you don't want that, I can just Control-Shift-click on that and manually specify frame range. You can also right-click on this and just say delete channels, which is that shortcut I just said, Control-Shift left mouse button. And let's just say I'm going to render out 24 frames just to preview 1 second of animation. And I'll go ahead and just save just in case I crash. And I'll press render to disk. And you can see now it is starting the render. So it'll just go through each of those frames, render it out. I'm going to interrupt that for 1 second. And I wanted to talk a little bit about file type. By default, we're using EXRs, which I definitely recommend keeping. This is the best way to do it to have maximum image fidelity. You can retain a lot more information with EXRs, especially if you're doing depth passes and things like that, which we'll talk about in the future. One thing I might want to do in our case, we're kind of a scrappier production here with what we're doing, and we don't have tons and tons of hard drive space. So I might recommend us changing our compression type for our EXR to DWAA, and then changing the level to 45. This is the amount of compression it will have, and this is the type of compression. Without going too much in the weeds with this is going to create a smaller file size when we render these images at the cost of some compression. So we're losing some data. So if you were in a really, really high-end sort of visual effects production, you wouldn't be doing this. But in our case, no one's going to know the difference, and it'll save us on our hard drive space, which we don't have an abundance of. So now that I've changed all these settings, I'm going to go back, render to disk. And I'll go ahead and let that render. And all right, so our render just finished, and I put up you could see the files popping up here in the File Explorer as it finished each frame of rendering. I also wanted to just show something to watch out for is how much video RAM or VRAM you're using on your graphics card while you're rendering, as well as your standard RAM. In XPU, you're utilizing your video card. If this got all the way up to the top, you could crash during your render. So something to keep an eye out on. You can see my video card is using a lot of RAM because I have multiple things open in the background. This scene is fairly simple, so really it probably was only using a few gigabytes of RAM. But keep that in mind. You can't have your scene be too complex based on the level of your hardware. All right, so I might want to just preview my animation. We can do that using mplay. So I can go ahead and open my Houdini launcher, and instead of launching Houdini, I can click on the little arrow and click mplay. And this lets you preview image sequences. So I will navigate to this directory. So I'm just going to copy paste this file path here and take a look at what we rendered. All right, so that's 1 second of animation. Yahoo! So that's the whole process, right? So now you would bring this EXR sequence into something like Nuke or After Effects or DaVinci, and you might do some final compositing or color correction on it. And then eventually you would export that out along with all your other shots as a video file, and that would be your final delivery format. That's it. I'm gonna just make a note here. I'm working in the ACES color space. I won't get into color spaces here, but if your images start looking weird when you import them into something like After Effects, likely you just have your color set incorrectly on your footage. We'll cover that at a later date in this class. And when I say this class, it doesn't really matter for people on YouTube since you're not in the class, but I'll make a YouTube video about something like that eventually. All right, so that's it for this sort of tutorial. Not really that fun, more of just a very sort of basic look at how to work with objects, how to work with your cameras, and how to actually get an image rendered out of Houdini. This is Damien signing off. Hoped this helped.